Okay, so back to this problem. Um, okay, so for part B, they're asking where the function is concave up or concave down, and then at the end for a point of inflection. So we need the second derivative. So the first derivative is here. And then so for the second derivative, it is 12x plus 18. All right, and then you've got to find where this is 0 or undefined. And then, so this is x plus 3 equals 0. And then that's, all right, so x is negative 3/2. All right, and I'm going to go back up here and factor this a little bit further, because when you're doing the number line test, it helps to use the factored form. Okay, so now to figure out where the function is concave up or concave down, I need to know, so there's Susan's table. I need to know where the second derivative is positive or negative. And then if, for a point of inflection, I want a sign change on the second derivative. So negative 3/2, that's negative 1.5. So like as testing points, I could do negative 2 and 0. So if you plug negative 2 into this factored form of the second derivative, you get a positive times a negative. So that's negative. And then a positive times a positive, positive. So for part B, they're asking, oh, wait. B and C. Okay, so I want concave up or concave down. So concave up from negative 3/2 to infinity. And they didn't ask why, but I'll say because f double prime greater than 0. And concave down from negative infinity to that, because f double prime is less than 0. And then, so, oopsie, sorry. So the very last thing, they're asking for the point of inflection. And the point of inflection is on the original graph. So since I did have a sign change at negative 3/2, the point of inflection is going to be negative 3/2, and then plugging that in to the original function. So negative 3/2, and I'm plugging it into the original. So 2 oh crap, I messed up. Okay, so okay, and I got negative 8.5. I'll get a fraction. Negative 17 over 2. Okay, so that's the point of inflection. Okay, so so that covered types 3 and 4. Now, moving on, page 2, number 36, this will cover type 5. But I have to actually add something to it. So we're going to find the absolute max and min on this closed interval of this function here. So what you have to do is use the candidates test. So need candidates test. So we go over here. X, f of x. Alright, so I put in the endpoints, -4 to 1. And then between here I need the critical numbers. And that's where you take the first derivative and set it equal to 0. Okay, so 4x cubed plus 12x squared. Okay, so those are the critical numbers. So then you put them in here, and then you get the outputs for these values by plugging in to the original function. Okay, so this is -2. All right, so okay, so you're looking for the absolute min, you need the lowest y value overall, and for the absolute max, the highest y value overall. So absolute min. Oh, and by the way, this is the candidates test showing this table. So the absolute min is f of -3, which is -29. And then the absolute max is f of 1, which is 3. Okay, so page 6, number 29, this covers type 6. Oh, wait. Covers type 6. Oh, yeah. Okay, so let me find it. Darn it, I think I threw out my packet. Shoot, I threw out the packet, so I have to make another. Okay, so this will be in the part 3 video.